Hey guys, so today I'm going to be teaching angles, arcs, sectors and rads and stuff for A-level maths. So this is a small unit, not too hard, just easy maths to pick up. So we start with a sector of a circle. So say we have our circle here with the middle 0 or O, whatever. And then you have an arc with a certain angle theta, or this is the bit we're using here. So this would be the radius, and this would also be the radius. And here is the arc, so from P to Q. And then we can make an equation with theta here. So we can say theta is equal to this arc here. So arc, so PQ over R. And we know this arc, if this angle is 360, so for the whole circle, we can say that the arc is the circumference, which is equal to 2 pi R. So if we put that in, 2 pi R over R, and we cross these out. And then, like I said, this is only if it's a full circle, because this is the equation for a full circle of the circumference of the full circle. So the degrees is going to be 360, which is 2 pi. And this is actually measured in rads, or radians, but I'm just going to write as rad. So we can rearrange this if you want to get what 1 degree is or what 1 rad is. But yeah, you can just divide that over, so 360 over 2 pi will give you your answer in rads. So if we wanted the length, so PQ, the length. So let's write, let's get a different colour. So the length of PQ. So we know this is the circumference, so this is the length of the whole circle, yeah? So if we only want this certain bit of the angle theta, all we have to do is times our equation for the circumference by theta. So if we've got 2 pi r, this is the circumference, so let's just C for circumference, and then times it by theta. This is currently in degrees right now. So like I said, all we have to do is divide by 2 pi to get in rads. So 2 pi here. And then we can cross out these. So now we know that the length PQ, or the arc, can also be said as RQ. So PQ, or if you want to write arc, is equal to theta r. And then if you wanted the area, so the area of this, so the area of the arc, or class this as a sector, so not just the arc now, we're talking about the whole thing, so this whole thing here. So area of the sector is equal to, so we know that the area of a circle is pi r squared, yeah? Well, I hope you know that anyway from GCSE. And then we're basically just going to do the same thing as we did for the circumference. We're going to times it by theta to get the specific sector. So times it by theta, and then we also need to divide that by 2 pi to get in rads. And now we can cancel these pi's here. So then we've got 1 over 2 r squared theta. So that is the area of the sector. And then there's a few more things. So you might get a question where they might ask you to find, so if we had a straight line going down here, so let me get my ruler out. If we had a straight line going down here, they might ask you to find out this coloured bit by here. And the way you do that is by doing the whole sector minus this triangle here. So if we wrote that, let's go under here. So let's say the shaded area, so shaded area is equal to, so the sector, which I'm going to class as S, just for sector. So the area of the sector, so let's write the area, so AR is for area of the sector, minus this triangle here. So the area of a triangle. And then nothing's perpendicular here. So we can't just do half times base times height for the area of the triangle. So we know that the area of the sector, just worked it out, is half times r squared times theta. So if you write that in, half times, we don't need to write the times. So half r squared theta minus, and then the area of a triangle. So if we have a triangle QOP, if I just write this again as P and C, and then you should remember that the opposite here would be the small c, opposite to this would be the small a, opposite to this would be the small b. So these two are the same. C, this is the angle. So if you remember, the area of a triangle is equal to half AB sin C, which is, so we've got A and B, which is the radiuses, and they're both the same. So we've got half r squared, and sin C is the theta, so sin theta. And then we can factorize, so we can get half r squared on the outside, theta on the inside, and then sin. So this has just been simplified a little bit. And yeah, that's all the rules you need to know really to answer the question. So we're going to go ahead and we're going to answer a question. So I've got a question down here. So this would be 4. This would be r theta. This would also be 4 because they're both the radius. So we know r equals 4 centimeters. And then it says points A and B lie on a circumference such as AB is 5 centimeters. So the arc is 5 centimeters. So then it says calculate the angle subtended at O by the arc AB. So this is quite a simple one. So let me just write in pink. So we don't know theta, but we do know the arc and we do know the radius. So if you remember, the arc is equal to theta r, and then the arc is 5 centimeters. Theta we don't know, and then r is 4, so times 4. Oh, that looks like 0.4. I'll just put a times here. Times 4 centimeters. So then we can say theta equals 5 over 4. But remember, this is in rads. Okay. So that's how much theta would be. Not rad, sorry, just radian. So that was quite a simple question for 2 marks. If you don't remember this, just go back in the video. And then we've got B, determine the area of the sector OAB. So OAB, so we want the area of the sector. If you remember, the area of a sector is equal to half r squared theta, because if you did the area again, the equation for the area of a circle is pi r squared, and then to get it for that specific angle, we're going to need to times it by theta, and then we need this in radians, not degrees, so we divide it by 2 pi, and then the pi's cancel out here. So then we've got half r squared theta. So we know the radius is 4, so half times 4 is 2 times 5 over 4. So let's just delete that because we can just cancel these two. Just cancel these two here. And we've got 5 over 2 centimeters squared. So yeah, that was quite a simple one as well. And then we've got one more question. So guys, we've got another question here. Says the diagram shows a circle with a centre O and radius r centimeters. Point P and Q are on a circle, and POQ. The POQ is 0.9. I'm just going to put that as theta for now. And then the tangent to the circle at P intercept the line OQ produced at the point S. So being this is a chord, we know this is going to be a 90-degree angle. And then it says the tangent is find an expression in terms of R for the area of sector POQ. So the area of POQ, the sector, so we know area of a sector is equal to half r squared theta. And we know theta is 0.9 radians. So if I put 0.9 over 2 r squared equals 0.45 r squared. So that's the first question. So let's put IA. So then II, or whatever, the length of PS. PS. So being as this a 90-degree angle here, we can do Pythagoras or trigonometry. So they want it in terms of r. So to do Pythagoras, we need this as well, and we can't put that in terms of r, so it's going to have to be trigonometry. So if we just mark it opposite, adjacent, h. So if we want the length of PS, so we want the opposite. We've got a here. So we're going to have to use cos. Tan. So tan theta equals opposite over adjacent, SOHCAHTOA. And then pi, actually no, we don't want to do that. Tan 0.9. And then when you're doing these calculations, guys, make sure your calculator is on radians and not degrees. Until you have the question with degrees, make sure you switch them back. So the opposite is what we want. So we'll just leave that as O, or we could say PS. So I'll just write PS, and then the radius is just R. So then we just switch these around. Oh no, sorry, we need this. So R tan 0.9 equals PS. PS equals, then if we just get our calculator, tan. So it says 1.26 R. So let's just say 1.26 R, just write that a bit better. 1.26 r to 2 decimal points. So that's that question as well. Let's just put this in centimeters as well, and this in centimeters squared. And then we got III, the area of the triangle POS. So it's got a 90-degree angle, so we can just do half times base times height. So half times height is r, so half times r, and then we've got PS, which is here, is 1.26 r. So 1.26 r, so radius. So then we can do 1.26 radius squared over 2, and then we can just divide this by 2, and then let's see what we got. 0.63 r squared, and centimeters, because this is length. Oh, area, sorry, this is the area. So centimeters squared. And for B, it says, given that the area of the shaded region is 95.22 centimeters squared, so the shaded region is here, find the value of r. So this area here, the shaded area, is going to be this triangle minus this. So we've already got the equations for these two in terms of r. So the area of the sector is that, and the area of the triangle is this. So then we can just go on straight to do it. So the shaded area, area is equal to the area of the triangle minus the area of the sector. So the area of the triangle was 0.63 radius squared, 0.63 radius squared, and then area of the sector was 0.45 radius squared, so minus 0.45 radius squared. And we can factor out the radius squared, and then we also know the shaded area is equal to 95.22. So 95.22 is equal to radius squared over that, times that, sorry. So then the radius squared is equal to 95.22 over 0.63 minus 0.45. And then just chuck that in your calculator. And I've got 529 centimeters r squared, so then r would be, and don't forget your plus and minus, so plus or minus 23, but being as this radius, you can't have negative length, so just put, therefore r equals 23 centimeters, because you can't have negative length. And there we go, guys. Thanks for watching. Leave any questions in the comments.